Good evening, guys. I'm Chris, and welcome back to this Wednesday's episode of Rift Amps. So I've been making progress on the first two 1 watt JCM 800 builds, the 1800 heads that I was doing as a Black Friday limited run. So transformers have arrived. The ones I had custom wound for me by Primary Windings here in the UK. My lovely transformer set, and I've just been doing my spacings out, make sure everything's happy with it. So yeah, so we've got a power transformer, main transformer, we've got a choke, and we've got our diddy output transformer that's gonna go there. I've already marked out the rest of the bits and done that jigsaw just to double check that everything there is where I want it to be, and that there's going to be no further issues. So that's that done. Front panel. I'll move these around. The spacing for the front panel I've marked on, and I'm actually keeping the same spacing as the original Marshalls had, albeit it's a smaller chassis, and we're rather than having the on-off switch and the standby switch, we're having an on standby off, so we can eliminate one of those switches. So yeah, it's going to look great. So that's coming on nicely. So I managed to keep that spacing, which means I can keep the dial sizes correct, use the right knobs that I want to use, all that kind of stuff. So I've done the front panel marking as well. The rear panel, not much to go on the rear panel, to be honest. We've got our IEC socket, which is going to go roughly there, and it's the type that I always prefer to use. It's got the inbuilt fuse holder. We've got a simple 8 ohm and 16 ohm outputs that are going to go there, roughly in the centre of the chassis, where I want them to be. But because it's going to be quite a large panel, and I know this is cut off, but just get the idea. It's going to be at least that long, isn't it? But it's only going to be held into place here. The risk is that this end of the panel will flap around. So we're going to have a tiny little mounting point there that we can run a machine screw through or something, just to hold that rear panel in place. I don't want to stick it down. I hate doing that. So yeah, these are coming along quite nicely now. I've done the boards. Both of those. Where's the other one? For the first two. There they are, all done. So numbered 1 and 2 as well. So I know which one is which because I've already drilled my mounts for the board. So coming along quite nicely, I think. What else have I got to do on them? Not much, to be honest. Just got to crack on with the builds. Now the transformers are here, I can make good progress. But it's one of those jobs that every time you sit down to do something, you realise you're still waiting on something else, or you need to do something else first before you can move forward in the way that you want, which is a little bit frustrating, but that's custom amp building, right? It's never straightforward. There's always many pieces of the jigsaw, and some of those jigsaw pieces have yet to be cut. So yeah, working on it. Good progress. Right, Q&A time. Richard McCutcheon says, "Hi Chris, the wife and I watched the videos. They are great. Well done." Well, thank you. Can I ask why you prefer the eyelet board construction over the turret type for mounting components? I was taught using the turret board method when we did electrical construction at Technical College, and lace harnessing with shellac to seal the knots. Those were the days. So we're going to talk about that one first. Either way, it's completely valid. The reason I prefer eyelets over turrets is simply one of cold solder joints. What I've found over the years is with eyelets, when you're building the amplifier, or turrets in fact, they're fine, they're great, they're exactly the same. But in the future, when you come to service an amplifier, if you've got eyelets, and especially where you've got underboard connections as well, when you reflow one of those solder joints, you're guaranteed to heat all the way through and to not get a cold solder joint. Whereas with a turret turret board, for example. So let's pretend this is a turret. Obviously, it's much taller than an eyelet. And let's say you're replacing a component or a wire that comes into the top of the eyelet. If you've got solder at the bottom, it's very difficult to guarantee that you're going to get heat propagation all the way through and properly reflow the joint at the bottom and not get a cold joint. And of course, if the board is installed in the amp, it's very difficult to get a visual on that as well. And I've seen this thousands of times on amps with turrets, that one that's had a service or many services over its years, and eventually you're doing a job where the board does have to come out, you flip it over and you could cold joint, cold joint, cold joint, cold joint, cold joint, because it's very difficult to ensure that. Whereas with an eyelet, just literally because of the size of them, you're always guaranteed to not get one. So that's all it is really. It's preventative measures for servicing down the line. That's the only reason. Also, I do like the way they look. It's a visual thing for me. Not everyone's the same. Some people prefer turrets, and that's fine too. But yeah, it's all about cold solder joints and preventing them when the amp is serviced in the future. Have you thought about constructing a stereo 5-watt head with just a volume and maybe a tone tilt control for the likes of the modelling crowd, Helix and stuff like that? I'm sure this could get some traction, just a thought. Yeah, no, I look into this every now and again. They're not financially viable for the numbers you'd have to do to actually make it worth doing. And there's other stuff out there. So it's a market I'm not particularly keen getting into because there's a lot of competition. It's not worth enough for me financially to get into it and do it. Unless somebody wanted to order a custom one. In that case, they're more than welcome to, but it's going to be expensive. So yeah, it's just one of those things that when you actually do your sums, look at it, could I actually sell X amount over the next 5 years to justify it? Probably not. Do I have a marketing budget enough to push it to that point? Probably not. Am I enthused enough about it personally to do that? Because if I'm not excited by it, it's not going to end up being a good product, is it? Probably not. So yeah, it's one of those non-starters for me, I think. I often look at those pedal amps and think I should have got into those years ago, but I'm just not into them. They don't make me want to, get out of bed in the morning and build them. Whereas a proper old school valve amp that's going to sing and scream and hiss and pop and have harmonics, screaming out of it, pushing the speakers in certain ways and all those good stuff that I really enjoy. That's what I'm excited by. So, sorry, Richard, probably not for the time being. You never know. But yeah, as I said, a bit of a non-starter. Okay, so here is another Abbott Tweed Deluxe 5v3. This one was dropped into me by its owner. I think he's had it for a while. It's got a couple of small issues with it. So he's brought it in to get those sorted, plus to give it a good service and a going over. The quote from the customer was, do try and make it as good of a 5v3 as you can, which happy to do. Happy to go through it. So let's have a look at this thing together. I'll show you what we've got, what my plan is for it, stuff like that. So hopefully you can all see. Very nice lacquered Tweed cab. I don't know who built the cab, but you can always tell with Tweed Deluxe cabs if they've been built well, because the really good ones are both light but incredibly strong without being overly sturdy. I know it's a bit of a can't be one without the other, but they really can. Some of the cabs that you can buy, especially from, I'll be polite here, cabinet builders who don't understand guitar stuff, they build them too strong. They're really rock solid, but they don't vibrate and move in the way they need to. whereas the good cabinet builders seem to understand that and know which way to go with it. And that's what this cab is. This is quite a nice cab. It's got the this style leather handle on the top, which they all eventually fail. It does happen. I always prefer to use the larger, thick leather handles, just because they take up the abuse a lot better. Although they're not vintage correct, so make of that what you will. We'll spin her around. I've already had the back off when the customer dropped it in, so that's why we're missing these 2 screws, but I'll take it off and show you. So we've got one of the chrome-plated chassis. Standard 5E3 layout, the 4-hole inputs, 2 for each channel, volume, master tone, fuse on top, and this one actually, rather than saying ground, says standby. And that switch there has been purposed as a standby. Okay, we'll just buzz this panel off. And then you can have a look. Inside, so Eli famously, when he was building amps, used red PVC wire inside, which is what you've got here. Incidentally, no shielding on the upper rear panel, but he's got some anti-vibration foam going on, or whatever it is. So, yeah. Zoom you in, we'll have a look. Okay, so pretty standard 5E3 layout, nothing, nothing weird going on. We've got our heater wire running along the chassis, which is fine if that's the way you want to do it. It's not the quietest way of doing it, but it's also not the noisiest. Perfectly valid if that's what you want to do. All this red PVC wire, a lot of it flapping in the breeze, but 5E3s tend to be pretty tolerant of less than optimal lead dress, so you can get away with doing it that way if you want. They don't seem to mind. Turret board construction. As we can see, we've got carbon comp resistors throughout, orange drop coupling caps, standard electrolytics. I can't see what brand these ones are. Can you see? SC maybe? Don't know, don't recognise them. Interestingly, the dropper, which originally was a 5K in the original amps, modern value we use this one here, the screen dropper. We normally use a 4K7. This one has got a 5K6 in, so for whatever reason, Eli was trying to reduce the screen voltage down slightly, but we've still got a 22K dropper here for the rest of the preamp, so I suspect that the preamp voltages are going to be slightly lower than usual, but might be the sound he was going for. If we look at the output valve sockets, you can see we've got he's used 470 ohm screen stoppers connected between pin 1 and pin 4. That's on both of those, and he's got grid stoppers 1K5s between pins 6 and 5. I normally do these the other way around, but as in my grid stopper will go between 1 and 5, and my screen stopper will be between 4 and 6. But that's an equally valid way of doing things. It just means that he's got these extra long wires that didn't need to be there like that. But at least he's got those resistors in. I mean, those 470 ohms 470 ohms really should be at least 1 watt as a minimum. But it's not the end of the world. It's not the end of the world. We'll get you some more light in there, shall we? Customer is running Jan Phillips 5Y3, which put out what you might call the correct voltage for one of these, but it all depends on what the mains transformer is delivering as to what that puts out. You'll see it's got this power scaling board here. Let me just move you around and show you that. There it is. Power scaling board here. It's one of the VVR units, but as you can see, it's disconnected. So it's not currently in circuit, and we're not sure why that is. Why somebody installed it and didn't wire it in. I think Eli installed it, and then somebody down the line has obviously disconnected it because they didn't want it. And from what I can work out, the way this amp was configured was that it dropped the voltage for the entire amp circuit, B plus rail, not just the output section. Because you can do it where you scale the output section, as we saw in that 65 amps Little Elvis, but keep the preamp voltages correct. Fine, okay, not a problem. Standby switch is there in circuit, and it's simply switching the high voltage center tap on and off, which is a valid way to do it if that's what you want to do. The only thing, but because this amp hasn't got a B plus fuse, I've spoken to the customer, we're going to add a B plus fuse to the side, especially as we've got a VVR unit. So we're going to go high voltage center tap to the fuse, then standby switch to ground. And then we will also have across the standby switch, I will use a bleed resistor, so we always get some current flow, because I want to try and protect this unit if we can. Rest of it, as we look through, all seems to be pretty standard. Not too bad. It's got 2 resistors in parallel for the output valve bias, so I need to get in there, see what values they are, work out why he's used those. Obviously we'll be rebuying this anyway, rebiasing this anyway. So that's overall what the amp is. What speaker has it got? It's got a WGS G12Q small magnet. Fine, haven't got a problem with those. But yes, so what do I want to do? Well, I want to give this thing a good service. I want to go through, make sure everything as it is. Often adding a 470k grid stopper to the phase inverter helps with blocking distortion, which I think is the right thing to do. We're going to reset the voltages in the preamp to be correct. So I'm going to swap this resistor out for a 4K7, see where we end up, and then adjust this 22K here if we need to, because I want to make sure those are balanced. Because of the way the lead dress is done in this, I'm tempted. Well, we'll stick it on the scope anyway and check for parasitic oscillation, but adding some shielded wire, at least from the volume pots back into V2, so this one here, is often a good and quick, easy way to fix a lot of issues that these amps can have. It's got protection diodes on the rectifier socket, so we're going back to those. I've just seen them. So he's got a protection diode there, just in case you get any flyback. So yeah, it's not bad. It's not bad. Customer doesn't want me to change transformers, doesn't want me to change the speaker. So that's that. I'll just have a look, because I've just realised that these 2 coupling caps here, normally they're hundreds, and he's got 10 nanofarads in. So usually these are, make sure you can see, these 2 here are usually 100 nanofarad each. The coupling cap to the phase inverter is usually a 22, and he's got a 22 in there. And the 2 output coupling caps are both 22s as well, and usually they're 100. So Eli's obviously tried to tighten up the bottom end on this, which may or may not be a good thing, because of the speaker choice. So do we go back to the original values and see how that sounds, or do we stick with those values? Well, I think the best thing to do is to check it on the bench, give it a play test, see what we think it needs. But before we do any of that, I want to get the VVR working. I want to get the voltages where they want to be. I want to get the bias right. So I've got a good foundation before we start messing around with revoicing. Russell Myback says, "Hi Chris, my 2 cents. Love the long form videos, love the short form videos, love the mid form videos." Great, love all the videos. Especially liking the basement videos. It's interesting to see how you approach your own amp. One thing I would like to hear is a sound sample from the amps when completed. Even if it's just strumming some chords on the black Les Paul hanging by the bench. That one over there. Perhaps Ainsley would load some loops on a looper pedal. Happy New Year. Well, that's exactly what we do. So I'm not an amp tech channel or a repair channel as such, because that's not primarily what I do here at Rift. I'm a builder. I'm an amp builder. I build and manufacture guitar amps. The repair side of the business just comes with the territory. I have to look after my customers, and I always want to look after my customers. So I take on repairs as well. And if I get anything exciting through the door, of course, I want to show you guys. But the repair side is not priority for me. And also, this is my full-time job. I'm not a full-time YouTuber who has time to set up fantastic camera angles and recording bits and pieces. You know, I've actually got a job to do to crack on and do this and earn a living. And so I haven't gone down that route, you know, of doing high quality sound samples of everything, simply because I don't really have the time. I'm a one-man band operation here. I'm working flat out. I'm trying to get everything done. You know, there's always deadlines, there's always work to be done and things that need completing. And if all I was doing was YouTube and just creating content for you guys, then maybe, you know, I'd have the time to set that up, but I don't. But if you watch this channel regularly, you'll see I do sound samples, whether it's Ainsley playing or myself playing. And I also do have a looper pedal, which both Ainsley and Danish Pete kindly provided some loops for, which I regularly run through and test through. That's actually a very important piece of test gear, is having a known good sound sample. You've all heard the loop by now, that I use to check everything. So yeah, please watch more videos. You'll see exactly how we do things. I will try and do more sound samples if I get time, but you know, as I said, I'm not a full-time YouTuber. I've actually got work to do, and to actually set up the microphone and record it, it takes time out of my day, which I need to be spending on doing work for paid customers. Okay, the Ampeg is all done. Unfortunately, it did need a new set of output valves and a new rectifier valve, because once we had it all reassembled back together, it was extremely rattly. So that's all now done and is waiting customer collection. We've had this Music Man 112RD dropped in for service. Really cool. So we'll get onto that at some point. This thing has come back. So some of the crackly issues have returned. Customer thinks it's based around V1. So I wonder if some of those PCB traces are unfortunately too far gone. But we'll find out when we get into it. But we will, yeah, we'll find out on that one shortly. Got an Ainsley Lister signature here. This is the one that I've just... actually, I don't think I've shown you this one, but this one's going off to America. I'm just covering up the address so you can't see it, GDPR and all that. So that's waiting UPS collection. That one's ready to go. Speaking of sound samples, Riper Snifle says, what mic was used with the clips of Ainsley? Sounds great. It's an AKG P120. I think we actually bought it, or Mrs. Riff bought it as a podcast mic or just for vocals and stuff. But turns out, sounds pretty good when recording guitars. I put zero effort into it. I just plonk the microphone in front of the speaker, roughly halfway between the dust cap and the edge of the speaker. Set the gain level so it doesn't peak at maximum volume or clip, sorry, and just press record, and that's it. I don't put any effort into it. I'm sure I can make these things sound better, but it's only because when I'm doing sound samples, these microphones that I use for my vocals, my audio, my speech, sound terrible for recording guitar. So yeah, if I am doing something, that's what I use. But yeah, it does seem to sound great. It seems to be idiot proof, so even I can use it, and it gives you a decent, realistic, real world sound sample of what's coming out the speaker. Okay, so amp is up and running on the bench. I've done a basic voltage map just to show you guys kind of what's going on and where. I've printed off an original 5E3 schematic for those that haven't seen one. And what I've done is every point where you find voltage, I've written on what the voltages in this amp are. Now, for the time being, we're going to forget what they're meant to be, and we're just going to focus on what they are. Okay. B plus rail, got a 5x3 rectifier installed. It has the power transformer. The high voltage winding is a 700 volt winding, 350 0350, and coming out of the 5x3 at B plus 1, our first node, we've got 400 volts DC exactly. Should we zoom you in? Zoom you in a bit. There we go. B plus 2, so after our screen dropper, 365, so we're dropping 35 volts across that resistor there. Remember, in the amp, it's a 5,600 ohm resistor, not 5k as originally installed. At B plus 3, we've got 268 volts, so we're dropping almost, just under 100 volts, 97 volts is it, across that 22k resistor that's there. The output stage, our cathode voltage, and you see it's shared, both cathodes are tied together, 25.7 volts. And in this amplifier, the resistor, remember it's two resistors in parallel that's actually installed in here. It's two 1Ks in parallel for 500 ohms, 498 in this case, so double the value that they originally had. Okay. Screen voltage is 339 each side, call it 340, so we're roughly 32, 33 volts lower on the screens than we are on the plates. Okay, and remember, these two figures are always measured in reference to the cathode, not to ground, because they're the ones that matter. Okay, our phase inverter anode voltage is 216 volts. The plate voltage or anode voltage of the preceding gain stage, what you might call the mixer stage, is 171.5 volts. And on our two channels, the anodes are 141 on the bright channel and 135 on the normal channel. Okay, so that's the basic voltage map. Bias figures are as follows. Our cathode resistor, 498 ohms. Remember, current, so our cathode current is voltage divided by resistance. So we do 25.7 divided by 498 gives us, in amps, 51.6 milliamps. So 0.0516 shared by two valves, and we're assuming that it's an equal split, gives us 25.8 milliamps per side. Times that in amps by your anode cathode voltage means we're running at 9.6 watts, which is approximately 80% dissipation. So this thing is running rather cool, and cool as in cold, not cool as in awesome. Zoom you back in. Okay, so that's a very basic voltage map. Speaking of voltage maps, when I do them, I measure everywhere that you can find B plus or DC voltage, I should say, in the amplifier, but then I also do an AC voltage map based on signal flow, so measure volts going into each stage and coming out, and therefore I know exactly what they should be or what the amp is currently doing. Cool, right. Okay, so the amp's open on the bench, and I've got a second microphone up against the speaker, and I want to show you the first issue that I found is that as you turn up the controls, you get quite a drastic hum. low frequency hum. Now I'm guessing that that's going to be 100 volts. Guessing. If we get the measurer, I'll be able to show you. Where's my app? So you can see already we've got quite a strong, approximately 50 hertz hum, but I think that's the air conditioning unit in the building. In fact, did I turn that off? Yeah, you can see that drop down. So let's turn up the, if I put it over here, can you see? You can. Problem is every time I talk it moves the wave, so I've got to be super quiet. But I'm just going to turn up the control here and we'll see which frequency gets boosted. See that at the top left there, 150 hertz we'll call it, which is the third harmonic of our mains frequency. Our mains frequency here in the UK is 50 hertz. When it's rectified, obviously it doubles, so it becomes 100 hertz, but there's obviously the third harmonic of that will be 150 hertz, which is where that hum is. If I turn the tone control up as well, you'll hear the top end starts to hiss more. Okay, happy with that? So we've got quite a large amount of hum in this amplifier and ripple that we're going to need to sort. We're going to find out where that comes from. We've got quite a large amount of hiss as well, although on the, yeah. I've heard worse. The worst of it is at the top end of the dial, which is where you expect to hear some anyway. So I'm not overly concerned about that too much. Okay, so there you go. So that's a basic checkout of this amplifier. I'll tell you what we should do. Let's look at the output on the scope. Into 8 ohms today. Yeah, 8 ohms today. We'll go into the normal channel. Let's move you over so you can see. God, I need to tidy my bench up, don't I? So we're ejecting a 1 kilohertz, 150 millivolt sine wave. That's the output on the scope. Let's give it a ground reference. There we go. Oh, it's not happy today, is it? It's not happy. Should we zoom you in even more and then you can see what am I actually talking about? Something weird going on with this amp. I can actually hear there's an oscillation going on through the output transformer. Oh dear, oh dear. So, I mean, I'm guessing we're getting around 8 watts out of it, so it's not healthy either, is it? It's down on power, it's not running right. We've got a lot to get fixed on this amplifier before we can call it good. So, I know what some of you are thinking. Is this a badly built amplifier that had issues built in from the beginning? No, I don't think so. There's always things that can be done better, but for the price point, there's absolutely nothing wrong with this amplifier, I think. I've seen a lot worse, and I've seen people who charge a lot more money for worse. So at the moment, I would say this amplifier is just in need of a good service and a sort out, and some general TLC and things improving. You'll also notice the eagle-eyed of you. The filter stack on these amps are 16, 16, 16 microfarads, and this one's got 22, 22, 22. So it has already got a slight increase in voltage, although not voltage, filtering. It's not actually, doesn't actually work out to be a huge amount. So I'm not overly concerned about that. So to summarise, what do we got to do? As the customer asked me to do my thing. So we're going to go through it. We're going to have fit B plus fuse, of course. We're going to reactivate the power scaling and check that that works. We've got to sort our hum out, find out where that's coming from. We want to sort some of this lead dress out because that can be done better. Or should I say, doing it better will help with the noise issues that this amplifier has. Make sure everything's tight and where it needs to be, all the sockets are good, and bits and pieces like that. So yeah, hope you enjoyed that checkout. Hopefully we're going to end up with a really nice 5E3. I'm just doing the underboards and flying leads and overboard wires on this PR18 board, so that's what I'm doing whilst we do this Q&A. Srolit, S-R-O-E-L-I-T, don't know how you pronounce that, sorry. Do you just take it in stride now that one of the best blues players living just drops by for a play now and again? Yeah, well, he doesn't just drop by, I'm afraid. He, as you know, one of our most popular amplifiers we do is the Ainsley Lister Signature amplifier, and Ainsley and I both agree that if you're going to do a signature model, you need to sign it off properly. And that's not just me, that's Ainsley as well. So he comes and visits and play tests and signs off every single signature amp that I build. He plays them and we tweak them if they're not quite where they need to be, you know, because component tolerances and whatever. And we spend the time to make sure that everyone that I build, he would take on the road and tour and record with and all that kind of stuff. If he wouldn't use it, it's not going out the door. So that's what we do with those, and we think it's very important that, you know, if you're buying a signature model and the artist has signed it to say, yes, this is good, that's actually the case. We want that for you guys. We think it's important. So he doesn't just drop by, he always brings singing. Ainsley and I have been working together since I pretty much started Rift. I've been servicing his gear for years and years and years. He does demos for me, all the kind of stuff. We've got a great working relationship. But it is nice to have him come in and try stuff. You're right. One, because he brings amazing guitars in, and he's a great player. But two, it's always interesting to hear my amp sometimes played by a player of that caliber, because I will then hear things that I don't hear when I play it, and that's a really important thing to do. So yeah, great comment. Thanks for your question. So I decided as it's the winter, that I'd leave out a little bowl of food for Tremolo every night because it's cold, it's difficult to hunt, and she probably gets a bit hungry. So I left last night a full bowl of food out, and when I came in this morning, as you can see, it's almost empty. But guess what? It wasn't the cat. I checked my cameras overnight, and this bloody crow has been nicking all the food. Arshist says, I picked up a 6768 Princeton Reverb with a Mojo Deluxe Reverb power transformer swapped in by the previous owner. I was dubious at first, but it's the biggest sounding Princeton Reverb I've ever played. Currently running it with a Celestion 10-inch gold. This amp slays. Well, I mean, it's interesting, right? Because the whole boutique, or vintage amp forum, hive mind, whatever you want to call it, says you've got to be bang on the original voltages for it to sound best, and high voltages always sound worse than lower voltages, and all that kind of stuff. But all the time we find examples where that's not the case, where the amp is arguably drastically improved by running these things at higher voltages. So yeah, proof's in the pudding. Don't take what you hear on the internet as gospel. Do your own research, find out for yourself, use your own ears. Remember, there's a difference between an objective opinion and a subjective. Is there a difference? That's objective. Do I like the difference? That's subjective. And yeah, my ultimate thing is, if it makes you want to play more music and write music and perform, that's the right answer for you, and that's the right, and if it does that, then it's right for you. But if it makes you want to spend more time tweaking it and adjusting it, then it's not quite right. You want to get into that music creating mode without worrying about the gear. So yeah, that's my take on it. Speaking of 1 watt amps, the custom one that I'm doing for Jerome, the little practice one, I'm kind of in the same stage as those ones. So I've started drilling and marking things out. I've made the board. You've seen this one before. And again, that was a similar case of just sorting out transformers and bits and pieces. The only thing was, because I had this chassis custom folded for me, there was no mounting point. So I looked at various solutions about getting a square punch, maybe bits and pieces, but in the end, all I've decided to do is simply drill and tap for some M6 holes. And this is going to be so light anyway, and this is actually going to be a sit on the floor chassis rather than a hang from the ceiling. So that's going to be the way I'm doing that. And I did a couple of test runs, and even though it's 2mm alley, with M6 hardware, it can hold a surprisingly large amount of weight. So yeah, that's still going to be fantastic. I'm really happy with that. So that one's coming along as well. I've also had an order in for a 5F1 Champ, which I haven't built in years. Or it feels like I haven't built one in years anyway. And so I was looking around, because if I'm going to build one, I might as well build another. And I found out the back of the workshop an old 5F1 chassis, one of these ones. It's not in the greatest shape, but I'm thinking about doing maybe a relict one, something like that. So if anyone's interested in a 5F1 Champ, maybe we'll do something different, maybe some different Tolex or whatever. I do have a chassis here which is unused. It's a bit scruffy, but I say if we do a relict one, it doesn't really matter, does it? We could do some cool things with that too. Okay, I've read this comment a few times over now to make sure I fully understand what Curtis is talking about. But he says my 65 Deluxe non-reverb original has 480 volts on the anodes, or the plates. Nearly 20 years ago it was 450, so I thought I must have measured it wrong. Now it's 480, so why are vintage Fender power transformers going up in voltage? Well, they're not. Transformer is just a step up or step down device. So if you're getting more volts out of the secondary than you were of the primary, the obvious reason is that there's more volts going in. Look into that. There could be another reason, as we all know, that as current decreases, voltage increases. So perhaps, in your example, the current draw of the B plus rail has dropped and therefore isn't sagging as much, so your voltages are higher. Again, something you need to look into. He also says 6v6s can't take this, right? Well, it's probably a bit too high for 6v6s as far as the datasheet goes, but there are many real-world examples where 6v6s will happily sit at that kind of voltage without even breaking a sweat. So your mileage may vary. He says, I have a vintage Amperex GZ34 rectifier. So will the amp handle the higher current of a 5Y3? So I assume you're saying there you've got the Amperex GZ34 installed in the amp. Will the amp handle the higher current of a 5Y3? 5Y3 has a lower current draw on the heaters. Is it by 100 milliamps? I think it is. But also has a lower current capacity that it can supply. So I wouldn't put a 5Y3 in that amp. You'll be stressing it a lot. So I think maybe you've got yourself a bit turned around there. But if you want me to clarify further, please restate the question. Maybe I've got confused there. But yeah, I wouldn't put a 5Y3 in it in a Deluxe reverb. Did you mean a 5U4? Because they pull 3 amps of heater current, not 2 amps. Maybe that's what you meant, and you'd have to check the specs of the transformer that's installed in your amp. Well, that's it then, guys. Thank you very much for watching once again. As always, please give this video a thumbs up, or your comments and questions down below. Subscribe, hit the notification bell if you haven't already. If you're feeling super generous, you can join the channel like these guys have, and I will catch you all at the next one.